Given the increased risk and imminent danger of solar flares, Sunspot AR3664 has rapidly gained attention from scientists. This massive sunspot, which is highly active and one of the largest during this solar cycle, is now a focal point for discussions regarding the potential impacts of space weather on Earth. In this video, we will explore the scientific aspects of this particular sunspot. We'll examine its similarities with historical solar events such as the Carrington event in 1859. Furthermore, we'll discuss the potential consequences if a similar event were to occur today and how it would affect us. Sunspot AR3664 is not just an ordinary spot on the Sun. It is an enormous one and among the most active during the current solar cycle. With a size of nearly 200,000 kilometers, it is more than 15 times wider than Earth. Its immense size allows it to be visible with basic eclipse glasses, making it a popular subject for educational and outreach programs aimed at generating interest in solar physics and space weather. This sunspot's activity serves as a prime example of how sunspots influence solar phenomena. Sunspots are cooler regions on the Sun's surface created by intense magnetic activity that hinders convection. These magnetic fields can become twisted and sheared, resulting in the sudden release of energy known as solar flares. These powerful eruptions emit bursts of electromagnetic radiation that spread across the solar system. On Earth, they can manifest as sudden increases in radio interference or disturbances in communication and navigation systems. Furthermore, this sunspot has been associated with several coronal mass ejections, CMEs. These remarkable solar events occur when large gas bubbles and magnetic fields are expelled from the Sun's corona. Depending on their trajectory through space, these CMEs can intersect with Earth's magnetic field, leading to geomagnetic storms that can disrupt power grids and satellites. So, once the Sun discharges this substantial energy, what will happen on Earth? Initially, the effects of a solar storm may not be immediately noticeable, as it takes a few minutes for the storm to reach our planet. One of the initial noticeable changes will be the increasing occurrence of auroras worldwide. This phenomenon arises when charged particles from the solar storm interact with the Earth's atmosphere. While these celestial displays are visually stunning, the positive aspects of a solar flare end there. The impact on our geomagnetic field would cause a widespread disruption in our technology. Satellites, GPS systems, and radio transmissions would experience significant interruptions. Your cell phone would likely struggle to receive any signal, leading to a decline in global communications reliability. The recent activities of this sunspot serve as a reminder of the Sun's potential to significantly impact modern technology. It highlights the importance of monitoring sunspots like AR3664 to better understand and prepare for potential disruptions. To closely monitor these phenomena, scientists employ various tools, including space-based observatories such as NASA's Solar Dynamics Observatory, as well as ground-based solar telescopes. These instruments enable researchers to closely observe the growth, movement, and magnetic characteristics of sunspot AR3664, leading to a better understanding of the processes that give rise to solar flares and CMEs. This knowledge plays a crucial role in enhancing predictions of space weather events, ultimately safeguarding satellites, power grids, and other vital infrastructure from the unpredictable nature of the Sun. Throughout the world, observatories and science centers are utilizing this rare event as an opportunity to educate people about the dynamic nature of the Sun and its impacts on Earth. Through projected images on sidewalks or screens, even those without access to a telescope can witness the rotation and changes of this specific sunspot over the course of several days. As we approach the peak of the Sun's 11-year activity cycle, the insights gained from monitoring Sunspot AR3664 become even more critical. The observation and study of this sunspot underscore the significance of these celestial phenomena and their profound impact on our technology-dependent world. The Carrington event of 1859, named after astronomer Richard Carrington, remains the most powerful geomagnetic storm ever documented. It was triggered by an enormous solar flare that directly impacted Earth's magnetosphere. The significance of this historical event in shaping our current understanding of solar activity cannot be emphasized enough, especially as we closely observe the behavior of Sunspot AR3664. The similarities between the Carrington event and the recent activities of this sunspot serve as a stark reminder of the Sun's ability to disrupt Earth's technological infrastructure. When Carrington first observed the flare that bears his name, it took less than 18 hours for the ensuing geomagnetic storm to reach Earth, highlighting the rapidity and impact of solar ejections. Telegraph systems across Europe and North America experienced failures, with operators witnessing sparks leaping from their equipment, some of which were severe enough to ignite fires. Today, Arkansas 3,664 mirrors this historical behemoth by demonstrating intense flares and coronal mass ejections capable of causing similar, if not more severe, disruptions to our technology. This is particularly concerning given our increased reliance on electronic systems and satellites. Following the Carrington event, auroras typically confined to polar regions were observed as far south as Cuba and as far north as Queensland, Australia, providing a vivid illustration of the powerful geomagnetic forces at play. Given the recent activity of AR3664, scientists and researchers have intensified their monitoring efforts. They recognize that the spectacular auroral displays indicate significant and potent movements within Earth's geomagnetic field, which could potentially foreshadow broader electronic disturbances. The cultural and scientific significance of the Carrington event continues to reverberate in contemporary times, serving as a benchmark for understanding potential outcomes of current solar activity. Discussions surrounding AR3664 in academic and public domains often touch upon various concerns, with the possibility of internet disruptions or widespread blackouts frequently making headlines. The infrastructure of modern society, intricately calibrated and heavily reliant on stable magnetic conditions, remains susceptible to solar storms on the scale witnessed in 1859. Post-Carrington, strategies have been developed to address these vulnerabilities, ranging from hardened electrical grids to satellite shielding, demonstrating ongoing efforts to mitigate the potential impact of such events. Moving forward, the knowledge gained from monitoring Sunspot AR3664 is being incorporated into global preparedness plans. International organizations such as the United Nations Office for Outer Space Affairs and the International Space Weather Initiative are actively working to enhance collaborative tools for predicting and mitigating the impacts of space weather. When contemplating a modern-day Carrington event, the consequences would extend far beyond the captivating displays of auroras. It has the potential to severely impact the global economy and disrupt everyday life. This is not merely a theoretical concern, it is a genuine possibility given the ongoing behavior of Sunspot AR3664, reminiscent of the 1859 event. A Carrington-like event in the present era would likely surpass anything we have experienced in the past due to our heightened reliance on technology. During the original Carrington event, electricity was just beginning to be harnessed, with telegraph systems representing the most advanced electrical technology in widespread use. Today, Our lives are intertwined with a network of GPS satellites, power grids, and fiber optic cables. A solar storm of severe magnitude striking in the current technological landscape could result in extensive outages and disruptions.